All right, so today we started with this warm-up in class, and I would like you to go ahead and hit pause and do this warm-up. All right, so I went ahead and went through and I did the domain, and because this is listed in roster as a set, I needed to use roster notation, so that means that each one of these is a point. It's not a continuous line, it's a discrete graph, so I went ahead and wrote down all my x values, smallest to largest, all my y values, smallest to largest. I graphed it, and yes, this is a function, and it passes the vertical line test. Now this one right here, I got negative infinity to infinity, and the reason why I got that is right here. Those are arrows. That means it's going to go straight that way forever until I get to negative infinity, which I can never quite reach, right? Until I get to infinity going to the right. Now, the y values were a little bit different. I could see that it was never going to go past -7. It was never going to get any smaller because that's a straight horizontal line. So I went ahead and put -7 and that it was included. Then up here I got to 5. I think that's right. 1, 2, 3, 4, 5. And I put 5 and it's also included. Now, is this a function? Well, look at this. No, this is not a function. It doesn't pass VLT, the vertical line test. So make sure you have that in your notes. So I would like you to put this in your notes. Go ahead and put f of x equals -3x squared minus 4. Find f of 0, f of 1, f of -1, and f of 2. So the way that I write these is I use parentheses to tell me what my input is. So basically this part right here is going to be my input, right? And I'm going to be putting it everywhere I see an x. So I'm going to write -3, my parentheses, which is my input is 0 here, and then this is all part of the same. So the -3, the squared, and the -4 is what I put down. And then I just go ahead and evaluate that. So go ahead and do that in your notes, and I'd like you to do that this format. So then this would equal -3. I'm going to go ahead and do that. 0 times 0 is 0, minus 4. And then evaluate. So then I end up with 0 times -3 is 0, minus 4, which equals -4. I would like you to write it out exactly like that, because when we go forward, it's going to make more sense, especially when we do a little more complicated. So more complicated inputs. So go ahead and put that in your notes, and I'd like you to do the rest. And do try to answer, is this equation represent a function? So now I have that. So for f of 1, I plugged in a 1. I did 1 times 1 is 1. I got -3 times 1 minus 4. -3 minus 4 is -7. I did -1. So -1 times -1 is a +1. -3 times +1 is -3. -3 minus 4 is -7. And then I did the same thing for f of 2. 2 times 2 is 4. -3 times 4 is 4. Or -3 times 4 is -12. -12 minus 4 is equal to -16. So I went ahead and every time I computed, so you'll see with the colors, that I did -3 times, I got -1 squared minus. Once I did the squared, I went ahead and just had the answer in that and continued up. Now, does this represent a function? Well, let's think about this. We know some things about transformations from last year, and we know some things about polynomials. This is a polynomial. You guys may remember this. We had positive, negative, even, odd. Now, do we remember that? So this is the leading coefficient and the degree. Well, the degree of this function is 2, so it's even. And it has a negative leading coefficient. So if it's even and it has that, it ends down and starts down. If it's even and it has a positive, you guys might remember this. You should. I hope you do. Odd ended up started down, and even odd negative ends down, starts up. So if we're looking at that, so we've got all of this, we know how our transformation works. Maybe we just know what the parent graph of x squared looks like, which, if we take all of that together, we know we're going to have. So when x is 0, which is right on the x-axis, right, we got -4. So -4. We know that it's pointing down. We know that it goes left or right 0 times because there's no parentheses here. And so this is what our parabola is going to look like. Something like this. This is, again, a rough sketch. So if we know it looks like that, and we know that there are no x values, there's no x value I can think of that I could put into that function that will give me 2 solutions. Meaning, if I plug in 4, no matter how many times I compute it, I'm only going to get whatever 4 gives. So if I do 4, -3, 4, and that's going to give me -3 times 16 minus 4, which is, so I get -3 times 16 minus 4, which is equal to -48 minus 4, which is equal to -52. So no matter what number I put in, I'm only going to get one answer. Now, a lot of people in class said, wait, this can't be a function. -7 is used twice. But that's okay, because 1 is a unique number and -1 is a unique number. So -1 is a different number that gives me -7, and +1 is a different number that gives me -7. So the x's aren't being repeated, and that's how we can think of it. Also, if we think of the graph, it's a parabola, and it passes the vertical line test. So yes, this is a function. It passes the vertical line test. So we're good there. All right, so go ahead and get ready for this slide. We are going to do this. So here's what I would like you to do. I would like you to read this. It says, find f of 2 for each of these functions. So f of 2, f is just the name of the function. Typically, if we are looking at different functions, they would have different names. So this would be f of x. Maybe this is g of x, maybe this is h of x, maybe this is t of x. It doesn't really matter. The letter in front of x, the parentheses, that just tells us the name of the function. So we're using function notation to figure this out. And I would really like it if you wrote under this, you wrote find f of 2 for each function, and underneath I want you to translate that to what English it was saying. So it's saying, find your output when your input is 2. That's what that sentence is saying. Something that we don't really talk about a lot in math is that math is like a second language. It's like a new language that we're learning. So I'm going to put this up here so you can start jotting this down in your notes while I'm talking. So how you read that, find f of 2 for each function, it's saying find your y, find your output, find your answer when your input is 2. So that's what it's saying. So if we look at this first table, we're going to find our input. Well, the inputs are going to be the x values, right? So the left side. And so I'm going to go down. Oh, look, here's 2. Well, when x is 2, what is my f of x? What is my y? Well, that's just its partner. It's right here. It's 4. So for this one, for this function, f of 2 is 4. That's saying, when x is 2, what's my answer? When x is the input, what's my output? Back and forth all the time. Now b is the same way. If we want to do that, we're thinking of x and y here, or x and f of x. Then we want to think of this. So if these are x and y, right? When x is 2, right here, what's the one that goes with it? It's right here. So f of 2 for this one is equal to 6. Oops, can't see it. Now, c is a little bit like what we just did, right? We have f of x right here. So we're going to go ahead and compute it. Equals negative, and how many? Right? And so then 2 times 2 is 4. Oops, I'm not in the wrong color, sorry. Which is equal to -4. Now this one might be a bit of a review from last year. So what we do is our input, our x, is 2. So we're going to come over, we're going to go to 2, okay? And what we're going to do is we're going to go up until we hit our graph. Whoops, there's our function right there. And then I'm going to write that point down. X is 2, my y is 3. So if I were to write the answer to this, I would write f of 2 is equal to 3. When x is 2, y is 3. Just like that. So make sure you got all of this down in your notes. Hit pause if you need to. Get this down. Okay, so now we're going to do this with variables. It can be a little more complicated. So the first thing I'm going to do is the same thing that I was doing before, and I'm going to use a as my input. So I'm going to write 3, and then I'm going to say a squared plus 1. So the biggest importance, the one thing that I notice that students struggle with the most with this, is that when we're doing the input, we're literally just replacing this. Just the x. So everything around it is part of the function. So if I'm doing that, then I get equals, so a, so this would be 3, and a squared is a times a plus 1, which equals, well, a times a is a squared, so 3 times a squared plus 1, which is just equal to, I'm going to distribute that 3 to the a squared plus 1. And now I've combined all my like terms, I've got everything together. So now we're going to do the same thing with this 3a. So we have 3 times 3a, the squares from the function, plus 1. Okay, so then we get 3 times 3a times 3a plus 1, because 3a squared is 3a times 3a, right? So then we are going to do 3a times 3a squared. So that equals 3 times, well, 3 times 3 is 9, and a times a is a squared. So the 9a squared plus 1. Well, we're not done. We distribute that first 3. So we have 3 times 9, so we get 27a squared plus 1, and now we're done. So now I'm going to go into the next few problems on the next video. If you've liked this video, hit subscribe. Don't forget to hit the like button. Isn't that what you YouTubers do?